Good morning, dear students. Welcome back again with the lesson number 4, measurement of matter. Here we are going to study certain laws regarding the chemicals. Now, in order to prove certain laws, here one experiment is being shown here. You can see here a solution of calcium chloride and a solution of sodium sulfate is there. Without reaction, they are together inside the funnel but without reaction. Their mass is 300.23 gram. Now, once it is mixed and the reaction has changed into white PPT of calcium sulfate and sodium chloride solution, but still the mass is 300.23 gram. Now, what does this indicate? This gives clear indication that even after the chemical reaction, the atomic mass will not change. That is nothing but our law of chemical combination. Take a solution of calcium chloride in a conical flask and a solution of sodium sulfate in a test tube. Seal the conical flask within an airtight rubber cork. Weight of solution is 300.23 gram. That is first equation. Now tilt the conical flask so that the solution of the test tube gets poured in a conical flask. Weight of solution is 300.23 gram. From 1 and 2, law of chemical combination is verified. That is molecular weight before reaction is equals to molecular weight after reaction. That is law of chemical combination. Now law of conservation of matter. In a chemical reaction, the total weight of the reactant is same as the total weight of the product formed due to chemical reaction, and this is called as law of conservation of matter. The law of constant proportion. Proportion of weight of the constituent element in the various samples of compound is fixed. The proportion of weight of carbon and oxygen in carbon dioxide is always fixed, that is 3 is to 8. For example, in 44 gram of carbon dioxide CO2, there is 12 gram of carbon and 32 gram of oxygen, so that the proportion by weight of carbon and oxygen is 3 is to 8. So the proportion of carbon and oxygen in carbon dioxide is always fixed. 3 is to 8, that will never change. Now, atoms, some information about the atom. An atom contains negatively charged particles called electron in the extranuclear part, positively charged protons, and neutral charged neutrons is present in the nuclear part of an atom. That everyone knows it, we have already studied. Now, size of the atom. Atom is very small, it is very difficult to find out the size of the atom, and therefore it is expressed in different units. Now what is that units called as? That is nanometer. Size of an atom is determined by its radius. The atomic radius of an isolated atom in a distance between the nucleus of an atom and its outermost orbit. The atomic radius is expressed in a nanometer. 1 upon 10 raised to 9 nanometer is 1 upon 10 raised to 9 meter equals to 1 nanometer. Cross multiplied, we get 1 meter equals to 10 raised to 9 nanometer. That was all about the size. What is the particular size of any of the atom? Now, with respect to mass, the mass of atom is concentrated in its nucleus and is due to proton and neutrons in it. So at the center of the atom, proton and neutron is there, that everyone knows it, that is inside the nucleus, and therefore mass is concentrated because of the mass of proton and the neutron. The number p plus n, that is proton plus neutron, in the atomic nucleus is called as the atomic mass number. Protons and neutrons are together called as nucleons. The relative mass of an atom. So, in order to calculate the mass of an atom, it was very difficult earlier, and therefore, one method was used in order to find out the mass of the atom, and that concept was relative mass. Relative mass is comparing the mass of the atom with the lightest atom. Let's see how. The hydrogen atom, being the lightest atom, is initially chosen as the reference atom. The relative mass of hydrogen atom, which has only one proton in its nucleus, was accepted as 1. The mass of nitrogen atom is 14. Now, how it is 14 called as 14? Why it is called as 14? This is how the relative atomic mass of various elements were determined. Now, why it is 14? Because the mass of nitrogen is 14 times greater than the mass of the hydrogen. So, we are comparing the mass of hydrogen with the mass of the nitrogen. That is why that is called as relative concept of the mass. But in 1961, carbon atom was selected as a reference atom. The relative mass of carbon atom was considered as 12. But even this method also failed, and at last they have considered a unified method of calculating the mass of the atom. Today, instead of relative mass, a unified mass has now been accepted as the unit of atomic mass, and it is called as Dalton. Its symbol is U. 1 U is equals to 1.66053904 into 10 raised to minus 27 kg. This was all about the mass of the atom. Now, one more topic is remaining, molecular mass and valency, which we are going to discuss in the next video. Till then, have a great day.